What is going on, everybody? Good to see you. Welcome back to the Daily Grind. Today we're here with our man SUMITOMO from Dynex. He is the what did you say you were, Sumi? I'm sorry. How do you like to be addressed?
That's how we started, right?
That's how we started.
No, I said chief architect is
Chief
nice.
architect. That's what I knew it was chief, but I was like, damn it, I can't remember the other word. Chief architect. All right. So I know typically this wasn't meant to be a crypto project, but it kind of turned into that in a sense. So I guess we'll just we'll run through kind of what Dynex is just for everybody here in the chat, and yeah, just give us a little bit of a background story, I guess.
Yeah, sure, absolutely. So first of all, thank you for taking the time. Thank you for having me. And excuse me because I caught a little cold over the weekend.
Yeah, he's a little bit under the weather, so bear with us.
Yeah. So basically, in short, what Dynex does, Dynex operates a decentralized computing platform, right? So what does this mean? So basically, we take computer powers of contributing miners and we utilize that combined computational power to perform computing jobs, right? And as you mentioned before, this project was actually not intended to be a crypto project initially. Initially, we wanted to address a very different problem, which is basically the end of Moore's law combined with, or the end of Moore's law, which is coming combined with the ever-growing demand for computing power driven by artificial intelligence, right? I mean, if you look at ChatGPT, as much as I love it, I mean, if you look at how much computing power they burn every day, it's just incredible. It's increasing. And yet we cannot make transistors smaller and smaller and smaller. So eventually, we are running into some sort of a bottleneck here, right? And that's why a lot of researchers are looking into what all falls into the category of like alternative computing paradigms, right? So you can compute with light, with quantum, with physics, with analog, with water, with DNA. There's a lot of research going on. And
real quick, Sumi, is
yeah.
your mic's clipping a little bit? I guess everyone's saying in the chat. I can hear it a little bit too. It's not really bothering me too much.
Maybe I should come a little bit closer to the microphone.
All right, yeah, let's do that. Let me hold on one second. Let me edit the mic settings. Just turn this back down. I tried upping the mic, but it's like that didn't change anything. So, all right, let's try it again, I guess.
Okay.
Sorry, I didn't mean to cut you off.
All right. So basically, what I was saying is we are running into a bottleneck at the end of the day. So we need alternative computing methods. We need faster systems in order to address this ever-growing demand for computing because of artificial intelligence. And when we started the project a few years ago, we were looking into what's out there, right? What is being done, right? And we looked at computing with light, we looked at computing with DNA, we looked at computing with water, believe it or not. And what really caught our attention was computing with memory stores, right? And I don't want to get too technical. I mean, let's cut me off if I'm getting too much into the details, but a memory store is basically a device which was first introduced in the 70s by Hewlett Packard. And what it is basically an element or a circuit element which combines memory and transistor functionality more or less, right? So what it means is you can build a circuit which does not need to continuously access memory and thus computing and CPU. You can basically inherently make it parallel, right? And that was quite stunning for us because the research has shown there are dramatic improvements to be done, right? So they achieved incredible results by utilizing memory-stiff technology. Now, having that said, it is important to understand that up until today, nobody was able to build really a reliable memory store as a physical device, okay? So there are memory stores out there, and there is also like Known, for example, is a project. They sell memory stores. Problem with all existing memory stores is they wear off very quickly, right? And they're also very expensive. So what the researchers did is what they do the same way what they do in when they basically calculate, hey, there's a new meteor coming towards Earth. How is this meteor flying? They basically simulate these memory stores, and memory stores are perfect to be simulated because it is not a quantum element; it's actually a real physical element, and everything physical, doesn't matter if it's a meteor or if it's a circuit or whatever it is, can be simulated or emulated, right? And the striking discovery, it was not done by us, but the striking discovery by the researchers was, if you simulate or emulate a memoristic device on existing hardware, and typically you would do it on GPUs because they're parallelism, you get the same features which you would get if you would actually have it in real. Obviously it's slower, right? But if you would build it, but you have the same features. You have basically long range order, you have self-organization, you have these instantonic jumps. All these features you would expect of an actual device being built, you find also in a simulation. The only drawback and difference is when you basically derive the so-called equations of motions, right, in order to simulate it of these devices, that you have to introduce variables, right? Basically, in our example, which we have published, we need 6 variables which are being introduced, and those variables are basically have to defined or found by the integrator. And that's basically, that was the reason when we said, and now I'm circling back to why we made that a crypto project, because initially the first experiments were in-house in our own labs, in our own computers.
Yep.
And in fact, actually, we were having here a cluster of 1,500 FPGAs, all cycle 5s, not very good for double precision, but nevertheless, I mean, we had a nice scale. But we realized very quickly that if you really want to simulate large-scale problems and do this really large scale, you run into a problem where you even buy all those FPGAs, right? And where do you even get it, right? And then we ported it to GPUs, which is actually much more suitable because on GPU you have stunningly, amazingly speed in terms of double precision now. And then we actually ran into an article where we saw, Ethereum is discontinuing proof of work. There's going to be a lot of dormant GPUs around, right? I know that especially old ones are being put on the shelves. So there's a lot of mining equipment out there which is not being used. We said, why don't we just take this equipment and try to utilize that mining hardware for computations? And that was basically the idea of Dynex. So we can basically go ahead and use that software. That sounds like a simple idea, and it actually became much more complex, as always with the projects, right?
Right. That's crazy. There's so I guess there's a lot of mic interference on your side. I think it's like clicking, kind of like staticky. Can you hear it, Yeti, or is it just?
Yeah, I can hear it my side.
Yeah, I guess it's kind of hard for some people to hear you in the chat.
I think it's just the very thick accent is peaking the microphone.
I think so. I don't know. It's not. I mean, on my maybe. Is it like a laptop? Probably what's happening.
Okay, so I actually reduced now the microphone. Is it better like this?
A little better. Let me see if I can. I'll up my side. Hold on one second. See if I can turn you up a bit. See if that's better, maybe.
Yes, 1, 2, 3.
Does that sound better?
That wasn't peaking.
All right, so it's probably so it's peaking on his mic then. That's what's going on.
Yeah.
Okay.
Because I had it at 100% the micro volume.
I mean, it's still a little bit, but it's not as bad as it was actually. All right, a lot of people. So I guess let's get the first question out of the way. Again, nothing here is meant to be disrespectful in any way, right? But a lot of people want to know if you have a voice changer because your voice sounded kind of different in one of the interviews you had, and then DJs, it was like, holy hell, it's talking to Arnold Schwarzenegger. So we were like, what is happening here? So
it's just different equipment,
Right. So I mean, I can vouch for the fact that microphones do make you sound different. Like when you change from like something like this to, a normal like potato mic, it changes your voice in a sense, not too much, but I mean, typically before we went streaming, right? Like I could hear in his voice that it's exactly the same as DJ's, even though he's under the weather, you can hear it still that it's got the same tone. So I don't think anything's going on here, but A lot of people were like, "Oh, it's the voice changer. That's why it's clipping." But I don't think that's the case. All right, so I guess on those FPGAs, right? So now, what's your plan when it comes to those? Are you planning on bringing FPGAs back to Dynex at all? Do you guys have a bit stream for it? Like, what's the deal there?
No, so basically, as I told you, we had been using Cyclone 5 Intel FPGAs initially, right? The problem with FPGAs is, especially with old models, double precision is actually really a problem there, right? So we, in a moment, we feel that GPUs are much more suitable for these kind of calculations. Everything has been optimized there. I mean, we did have a few requests from FPGA producers. Let's see where that goes, but I don't see really that much of a performance increase if you take, let's say, the latest versions of FPGAs, right? Over a really nice GPU, because I mean they are just made for it, right? I mean, what we are doing is we are running an ODA integration of the simulation. If you look at the reference code and if you look at the way it's been done, it's basically all just loops, right? And calculating voltages and applying derivatives. So this is almost like an example task for GPUs. So I believe that Dynex will be for a long time really GPU friendly, and not even talking about ASICs, because that's actually unthinkable, because we are constantly adding new job types. We have updates to the implementations. So it's not like that this is like ironed out or set in stone what we are doing, right? Because right now we are supporting, for example, optimization problems or constraint satisfaction problems. Next is coming machine learning. That requires a major update on all miners, for example, right? And then there will be other things coming, like federated learning, for example, right? And the list is endless. So we need a flexible development environment that GPUs can be updated from time to time, or the miners can be updated. That's possible on FPGAs, but on ASICs, almost impossible.
Interesting. All right. Let me see. So we had a question in the chat. It said, will Dynex change the algo in the future again? Is that something you guys have planned, or do you think it's going to pretty much stick where it's at?
So we're quite happy with how it's set up. I mean, currently 95% of the energy is being used for useful work. 5% is being used for hashing, right? Because we basically had to combine the block hashing with useful work. So far, we have no plans of changing the algo. I mean, we could potentially, but in the moment, we are quite happy with how it is.
Gotcha. Sumi, is there any way you can turn down your gain a little bit? Is that possible on your mic?
Second.
Yeah, no worries. Sorry to be a pain in the ass. I totally should have talked to you a little more before the stream. My bad. Mr. Yeti, do you want to grab one of the questions that we had?
Sure.
I guess one of the ones that are a little more complex than something I would ask.
Sure. I mean, the one big question I had was, how are you implementing when you switch over for proof of useful work? So you take a big chunk of, say, hash rate that's on your network, move it over to do the proof of useful work side. Are they actually still mining on the blockchain, keeping the blockchain moving, or do they physically come off of one, go to a side chain, and then come back?
Yeah, very good question. So basically, you can think of the useful work being done on our chain as basically like a one gigantic ODE integrator, right? So basically an integration of ordinary differential equations. Now, the way it works is, if you take, let's say, an optimization problem. This optimization problem is loaded from the or served from the malloc system, and malloc is important to understand. Malloc is the Dynex, the place where Dynex jobs are being scheduled, where work is being distributed between different miners, right? So let's say you start your miner asks malloc, hey, what's the work? He gets a work file, right? And then this work file is being translated into these equations of motions, which I described before. And then we do an integration step. right? So basically, typically, let's take a problem. Let's say we have 100,000 variables. So basically, it's 100,000 voltages, and these 100,000 voltages are updated in the first integration step. And one integration step over all variables allows you to make one PoUW hash. Okay, so basically one hash equals one full integration step. And basically what happens is that basically one integration step is being done and one hash is being calculated. Next integration step is being done, next hash is being calculated. So basically they are absolutely entangled, because when we started, we were actually not considering the level of potential malicious activity going on mining, right? And we actually had to really hard entangle everything. So basically, when you do an integration step, right, you create a new energy level, for example, right? And you create a new local minima, for example. You create new assignments. So those are being used, and then they are back-checked by the job scheduler if you're still eligible of doing the hashing, right? Now, since the commercial miner took over and they integrated also the hashing on the GPU side, so that's basically much easier to really entangle, because on the GPU side, you basically do the integration step, do the hashing step, do the next integration step, and so on and so forth. Initially, the first releases had these two parts separated between CPU and GPU. Actually, that was the first releases in December, which basically created all sorts of limitations, also in terms of hash rate, because if you didn't have a strong CPU, you couldn't mine, you didn't get the hash rate, and so on and so forth. It was all sub-ideal, but it was an iterative process, right? Because what we're doing here is something we have not done, or nobody else has done before, so we have to learn while we are basically rolling out features and do it step by step, right? So, but as of now, everything is done on the GPU, hashing and PoUW, and one hash equals one integration step. So now if you look at our hash rate, for example, we have, let's say, 300,000 kilo hash, right? 300 mega hash, right? That means we're doing every second 300 million integration steps, which is quite remarkable already in terms of size.
Interesting. So I guess to clarify, Fully Electric said,
would you like me to trim that down for you,
well,
John?
he said, so the miner never gets moved from the supporting network. In the proof use will work, they basically both do them simultaneously, right? Right.
Think of it as basically one process, like this.
Right. Right. Just kind of meshes together. Interesting. All right.
Yeah.
That's what, yeah, Fully Electric actually summed it up in the chat. Thanks, buddy. Yes, that's exactly what they meant. He said, wow, that's crazy. And it's working with a question mark. So, I mean, I would assume so. It seems like it's working fairly well, right? At this point.
I know that Mad Electron just put a question saying, what's going on with job 3 taking forever to solve that job? So I guess there's, much like with any development, like you're still very early on in that development, and there's more than probably a list and an arm's length long of things.
Yeah, I mean, the thing is, yeah, no, people need to understand. I mean, we are developing and we're still building. I mean, we don't even have a marketplace yet, right? I mean, all the jobs you see, they are being posted by us or by customers talking to us, or we talking to them to test run the system, right? Obviously, we feed the system with currently unsolved problems, right? So we did one for the nuclear waste optimization, which is a super tough one, unsolvable usually with current technology, right? But we are building this step by step, right? So later this year, we're going to have a marketplace which will make this whole thing self-service, right? So basically, Yeti, you can go and say, hey, you know what? I want to launch a machine learning job. I want to train my whatever OCR, whatever graphic, whatever machine learning model you want to do, right? You post that job there, you get it done, etc., etc. So it's people need to understand that this is an iterative process, a development process. We're right in the middle, and there are certain things which obviously need to be done still, right? Another very important point is, for example, decentralizing malloc, right? Because basically malloc is currently centralized, right? I mean, we do have decentralized endpoints, but imagine if we would have started this whole thing off with decentralized malloc and machine learning and this job, if we would have just launched it in December, I mean, we would be already not existing anymore. So we said, okay, let's do it step by step, right? I want to do first constraint satisfaction problems. Then afterwards, I want to do malloc centralized that allows us to learn, because what malloc, I mean, the job of malloc is extremely important, right? I mean, you need to understand this, you need to realize that there is constantly miners coming and going, stopping their machines and so on. It's a highly malleable environment, right? So you need to deal with that. And only now we reach a point where we are feeling confident that the constant parameter optimization process, the malloc system is stable, the job scheduling is good. Now we are introducing machine learning shortly, and this is an open invitation, by the way, for everyone to become closed beta tester for machine learning job type. Please go to our channels and subscribe to it, because it could be really interesting. And we need your feedback, and we need people to test drive our machine learning job. Right? And as a next step, we're gonna, as presented on our roadmap, we're gonna put malloc inside the node, right? Being part of the decentralized work, right? Which required, firstly, obviously, to learn the lessons. And only then, when the entire ecosystem is being built out, then you will see, obviously, a constant stream of machine learning job, of optimization jobs being scheduled. The first version was actually only able of handling one job on parallel. Now we have parallel job handling, right? I mean, there is a number of jobs being solved, but they are being solved very quickly usually, right? But you can see them, it works really, really nicely. Sometimes we have 2, 3, 4 jobs being run.
Right. Wow. That's crazy. All right. So Yeti, why don't we do it like this, right? I'm going to have you, the questions we had in Discord.
Yeah.
Do you want to take those, and I'll follow the chat questions, because I feel like this is going to be a bunch. So we'll take the ones,
Oh yeah,
as many as we
there's a
can,
lot
right?
coming in. I've just noticed.
Right.
There was a follow-up question to mine, and
Yeah.
and that was whether there's a difference in power consumption while it's mining against proof of useful work, because obviously, if we've got our cards specifically overclocked for mining, is that going to actually impact your proof of useful work benchmarks and job scheduling?
So basically, initially, when we had our first releases out, we had these real issues of constant changing power draw, right? Because basically we had low power draw because actually the proof of useful work part requires not a lot of power, and then it made it jump, right? It jumped down and up, and was waiting for other cards. So the current miner implementations, all of them are all super smooth in terms of continuous power draw. Overclocking is not a problem, right? Actually, the faster it is, the better it is for us, because it's because of the entanglement, right? You can basically max it out to the limit, right? It will tell you anyways if the proof of work functionality would not work anymore, if there would become miscalculations, for example. I mean, there are possibilities, and we have that sometimes, but then you would not be able to mine anymore. It would give you malloc errors, right? So the community has done a tremendous job in going through all different cards, overclock settings, and I don't know what, right? In order to find out what is the best level of proper proof of useful work, power consumption, and effectiveness, right? And then we have a very thriving community on Discord, really trying to find out what are the best overclock settings and everything for the miners. That has grown up tremendously since commercial miner entered the stage, so to say.
Well, that's certainly good to know that we won't have any weird differences between when you're mining and doing proof of useful work. That was one thing that I've wondered since everything was introduced, is what's the impact on the card doing one to the other. So yeah, that's really interesting. Thank you.
We had another question actually about proof of useful work. Are we going to have more than PCIe, PCI 1Xs for proof of useful work, kind of like the 16 slots? So you're going to need full size for your type of proof of useful work, or I guess, could you elaborate on that a bit?
No, because it's a simulation. right? So basically data is loaded in the beginning and then only integration steps are being performed, right?
Okay.
So basically we do not need a constant communication of data from the GPU backwards to us. What we tell the GPU is, here's your set of parameters. Remember when I was explaining the parameters we have to introduce, right, for the integration.
Yep.
And then here is the problem file. Here are the initial parameters. Let's go. Right? And then he can continue. And we actually, for us, it's enough to update it like every 60 to 600 seconds, actually.
Interesting. Okay. Yeah, I figured that was going to be the answer. No, you don't have to have more than that. But I know, like, Flux per se I'm sure they're going to have full 16 slots to perform their proof of useful work. So I guess some people are just kind of confused on the whole situation, like how yours works versus theirs type deal.
I guess it comes down to a memory bandwidth thing, right? So obviously widening up the PCI bandwidth means that you can, read to and from the card much quicker. But obviously Dynex loads up their jobs at the beginning, meaning that, correct me if I'm wrong, but you would load it directly into the VRAM of the card, therefore not having to worry about the communication constantly.
Correct. Except the job is finished, right? Then the miner basically gets reloaded, right?
Yeah. So it flushes down what's stored in VRAM and carries on doing what it needs to do. Yeah, nice.
All right. Uncomfortable question time. Somebody in the chat asked, can you ask Sumi why he is so secret, I guess, about his identity? And I know everybody has their own reasons. I had mine at the beginning. So if you want to answer that, please do. If you don't, just tell me skip.
It's very simple. First of all, nobody is really secretive about identity here, right? I mean, this project is 100% self-funded. We have been doing this since years, and we're going to continue funding this. So there has been no airdrop, no pre-mining, no nothing. So I think we can determine the speed, when and how quickly we establish intellectual property protection, legal law, and all these things, right? We have decided now on the venue of the venture, and this was actually also not that simple because there's a lot of moving pieces, right? I mean, for instance, Switzerland used to be a great venue. There's new laws coming out in Switzerland, right? Now we have Europe with the new crypto laws, etc., etc. You have Asian countries. So we decided to incorporate in Liechtenstein, which is currently in the works, right? Which is for us a pretty stable and solid place to be, because first of all it falls into the European Union, and with all the upcoming regulations, we feel comfortable that we fulfill it because we are a true utility coin and not just some token, etc. And once we are done with that, we're gonna do, or on parallel, we are doing intellectual property protection and if you would say now, yeah, but the source code is open source. Yes, of course, it is open source, but the malloc part and the job scheduling and basically the distribution, how to learn and tune parameters is not, right? And that's actually a key to it because it would be fairly simple, right? Otherwise to run it on your own machine, right? So there's a lot of intellectual property protection required. And there's also tax considerations, which all to the point that people of the team might even move around, in on this world. So I would really ask people to respect our pace, but how fast we do things. Obviously, eventually we will docs and make a nice thing, a nice announcement around it. But there is no any other reason, and I think that sums it up pretty nicely.
Yeah, that's good enough for me, man. Good enough for me. I knew that was going to be a weird question
Really
to get
cool,
answered right.
Fact for you about Liechtenstein is there's actually more businesses registered in Liechtenstein than people that live there.
Oh, really?
Yeah. Oh, yeah.
Well, that's neat. Didn't know that. Interesting. All right, Yeti, do you want to grab another question you think from ones we had earlier?
Let's have a look. Yes. Mark Marry asked in the chat, will other developers be able to build on the blockchain? And what will the use case be, obviously, once they're implemented? So is it going to be more dApps, or is it going to be more along the lines of nodes with running alternative methods similar to what Flux does? Or is it going to be more along the lines of an ERC-20 style Ethereum network on smart contracts?
Yeah, so basically, as the blockchain is being used, so the Dynex are the currency for computations, right? So our core focus is making interfaces to standard protocols out there, right, which allow us to do computations, right? So we started with optimization problems because this is a very well-defined topic. Not too many people know about it, but it's actually being applied everywhere, right? I mean, SAT problems, max SAT problems, QO problems. It's a highly relevant topic, and there are standards for it, right? Machine learning is next, and we decided to go with PyTorch integration, right? So for us, the most important part is to basically get support from the community to get it integrated everywhere possible, all the way up to TensorFlow or being other machine learning frameworks. That's actually where we need the integration. And as I said before, as Mallob is going to become part of the node itself, and everything gets decentralized, right? So the real work will be opening up interfaces, right? Opening up the world of interconnections into the nodes to be able to compute on the platform. That's actually our real focus right now.
Awesome. All right. We did have a couple questions back to those FPGA stuff. So I'm sorry, forgive me if you already said this. What happened to those 1500 FPGAs? Did you guys rent those? Like, what was the situation there? How did that work?
So we actually bought it from an old mining farm.
Oh, okay. Interesting.
And yeah, we repurposed them. The thing is, on the Cyclone 5, you cannot run Kryptonite, for example. You cannot run any proper mining algorithm. I mean, what you can do is you can use it for experimental setups. We still have them here. Okay. They are actually switched off in the shelf right now, but I mean, at one point we're going to find some other purpose for it. But they cannot really be repurposed for modern mining.
Okay. And then somebody else said, like, why would you guys pick FPGAs to test a GPU mineable algo? But was the algorithm changed at all, or has it been the same since?
No, I mean, that's at that point we did not even think about a blockchain project. I mean, that was initially we wanted to build the fastest computing platform. Right. And okay. It was quite obvious as we got a nice offer on the table, right, to get those pretty outdated actually FPGAs. So we said, okay, let's grab them, let's see what we can build.
That makes total sense, actually.
Yeah.
Yeah, no, I got you. All right. That's yeah. I figured there was some sort of reason behind it why you choose those to start with, but I guess getting into crypto towards like, end game type deal, it wasn't really the beginning plan. It makes sense that you guys have moved, like, I guess backwards, right? A little bit to GPUs instead of FPGAs. I don't know.
Yeah.
All right, Mr. Yeti, what do you got anything else you want to?
Sure, yeah. Another one was why Dynex? What's with the name? What does it mean for you guys or for everyone else using it?
Well, actually, it has no real. No, there's no story behind it. Oh. Maybe we should make one now. We were sitting there and we had actually other names and other considerations before, and nothing was really catchy. And the thing is, especially when you want to address a large market, you need to have a really strong name with only a few characters, right? And then basically everyone was putting together names and was discussing. And then we found Dynex, and we found it's just associated with strong, with network, with innovation, right? And we just liked it. But there's no real good story, unfortunately.
Oh, that's a shame. I was hoping for a good story.
Same thing with Neoxa. Yeah. They had we were like, why'd you pick that name? And they're like, we have no idea. Because it just honestly, when you're picking a new name, it's kind of like even like my channel name, right? It's weird no matter what you're trying to pick. And it sounds weird for the first couple months after you actually land on a name you want to use. It's just one of those things, you don't know why you picked the name you picked, but it is what it is. Yeah. Man, that's funny. All right, so what else? Let's see, Mr. Yeti, is there any other big ones in the chat on the side that we actually had in Discord that you wanted to get to?
Yeah, we got a couple from SerpentX that I can definitely put out there. So will you be able to choose the computer workload you want to work on or define a genre that you're willing to use your resources on?
Yeah, so that we heard that actually quite often, and that's actually interesting. I must say, this is definitely not for release 1.0 of the marketplace,
Sure,
but going
I can understand that one.
going forward, it totally makes sense, because there might be people who would be, more interested in let's say environmental problems, right? They say, okay, I want to like work on environmental problems,
Or
so
something
as
like
soon as
cancer research, I guess,
or
would be the
cancer
alternative,
research or
something
drug
along those
discovery,
lines, yeah.
exactly, right? So we have serious considerations of actually, categorizing problems, and also let people choose, because I mean, the MATLAB system is anyway scheduling it, so it's not, from a technical perspective, it's not hard to basically allocate preferences, for example. But that's definitely something for the roadmap for next year, when the marketplace is rolled out, when everything is running smooth, and when we have enough jobs running through the system.
Nice.
All right. Let's see. So I guess Serpent, this is another one from Serpent. He said, with the rise of proof of useful work with various projects, including but not limited to Flux, how does Dynex differentiate itself from other projects?
Yeah, good, absolutely good question. And I think I want to really emphasize that other projects, or most other projects, are basically sharing the GPU power more on a technical perspective. What we are doing is we are running ODE integrations of circuits which are being simulated. That's a totally different approach, right? So you cannot, for instance, come to Dynex and say, you know what, I want to render my video here, right? It's not going to work. You need to go to some other platform which provides that service. But if you want to perform a computational task, which we have defined, which is like machine learning or satisfaction problems, optimization problems, then you probably will not find a more efficient way of doing it currently.
Right. It kind of goes back to the 16x versus 1x slots. Like you guys, you don't need to have that many lanes or whatever, to get things through, because it's simulation. Interesting.
Yeah.
All right. Let's see. I guess another one from him was, please define some of the use cases for the Dynex ecosystem. What are the tangible real world benefits, I guess? I mean, I guess you kind of explained that a little bit, right?
Well, yeah, but let me give a few examples. So first of all, we have this whole category around optimization problems, right? So optimization problems is a little bit abstract for people to grasp, but it basically, we can assume that every global 2000 company is at a scale where they have optimization problems of various kinds. You have it in fintech, right? Portfolio optimization, etc. Pharmaceuticals, drug discovery, protein folding, these kind of things. Genomics, DNA sequencing, right? One example we showcase on our side is actually architecture. And I give you an example in one sentence, what they did. So they had to build a pedestrian walkway with an organic shaped roof. And the task was, how do I position the columns in an optimal way that still pedestrians can walk, and this whole structure is stable, given that the whole roof is organic shaped. And that task takes a human, even with the help of computers, a month.
Yeah.
And they ran the job through Dynex. 1 minute later, the result was there. And they said, put 10 columns like this. And the statistical engineer was like, wow, I as a human would have never thought of something like this, right? So there's a lot of use cases along with optimization problems. But I think the most understandable and graspable use case will be machine learning. So everyone who trains a neural network can use Dynex going forward to lower the number of training steps required to get it to a certain level of accuracy. So basically, even today, you can use the D-Wave quantum machine, for example, for optimizing your pre-training or your training of your models, right? Now, obviously, that's very expensive and it's very limited in terms of number of qubits you can use. on our platform, we have no such limitation, right? And there's research out there, and Yedi, I'm happy to share that with you because it's really exciting. They used a reduced MNIST data set because they could only use a very small number of qubits. They basically pre-trained. They ran the training through the D-Wave quantum annular, right? And they managed to reduce the number of training steps, I think, from like down to like 10 or 20%, right? Required. So they saved 90% of training energy. Now imagine you can do that for a large scale training model, right? And we think when we roll that out, that will, first of all, attract a large number of users because it's just going to be based on Python, on PyTorch initially, and then other frameworks. So people can just simply say, you know what, let's try it. And if they can save 90% of training time and run it through the Dynex networks, similar to using a quantum machine from D-Wave, for example, at a fraction of the cost and speed, that makes a great business model.
Oh, 100%. Yeah, no, that's crazy.
So would you actually consider yourself falling somewhere in between a traditional, CPU and a quantum computer then? Somewhere in between, almost like a bridge.
It's like I would call it more like quantum-inspired computing, actually.
Yeah.
Right? Because on some use cases, I mean, we have demonstrated, not only we, other researchers also. There's papers and peer-reviewed papers and everything out there. It is possible, right, with memoristic technology to basically reach quantum similar efficiency. That's how I would basically call it, or quantum computing like efficiency with GPU hardware.
Nice. Did that answer your question, Yeti? Make you feel good about it? All right. So I guess I think I know the answer to this one. I'm assuming not, but somebody asked if you've been previously involved in any other blockchain projects.
No, I mean, given the history, right? No.
Okay.
But obviously, when we decided we want to become a blockchain project, we actually got developers on board which definitely have blockchain experience,
Smart. Yeah. No, I mean,
that's the way to do it.
There's really no other way, right? You need somebody that's had their feet in the water a little bit, right?
Good question in the chat. There's a really
good
question.
Take it away, man.
How does Dynex determine the ethics behind computational jobs? For example, brute forcing, malware decryption, etc.
Yeah, that's an excellent question, because obviously, I mean, now we have been talking about the bright side of Dynex and how great the computations are and how fast everything is. That also comes with responsibility.
Yeah.
Right? Because imagine if, you could technically, if this network becomes large enough, it could become a security threat eventually.
Yeah.
Right.
Totally
and
true.
Yeah, so we have our plan is to establish an ethical committee, and that ethical committee will oversee very large computational problems. Because first of all, small computational problem files can never be of any risk, right? So if you would like to do an algebraic attack on, let's say, nuclear power codes of the United States, that would be a very large computational problem. And all those problem files also come with a certain fingerprint, I would almost say, right? Because they are not machine learning tasks. These are all constraint satisfaction problems, typically, right? And they are pretty, you can identify them some sort of, right? But in general, in the marketplace, if somebody comes with a really huge, gigantic problem and it has some red flags, it will go to the committee, and the committee will speak with the customer and say, what is it? What are you doing there? And by that, we're trying to enforce ethical use of the platform as much as possible, obviously.
Nice.
There we go. All right. Another question we had in the chat. Let's see. Why does the solver reward go to the individual miner who solves rather than the pool who solved it? And will this change in the future?
Yeah, I mean, I'm aware of this discussion, and the business model, when the marketplace is live and everything, it's mostly the block fees which a customer pays, right? And this block fee is distributed equally to all the miners in the pool. It's all fine. we introduced the solution reward as a sort of a motivation, right? It's more like a lottery, really, right? For people to stick with us and to mine, but it's obviously not something you can do in the long term, in the long run.
Right. Gotcha. Okay. Ooh, Fully Electric asked kind of an interesting question in the chat. See that? He said, can Dynex be used to crack a 12 or 24 word seed phrase wallet? Like, is that possible for you guys to do? Obviously, that's kind of like a, I don't even know if I want you to answer that, to be honest.
My opinion would probably be it would be borderline right now, given that the network's not fully optimized as best as it could be right now. But in the future, as more and more miners go on their network, the more computational power they hold. If you put everything they had on it, it'd probably give it a good run.
Right. Anything's possible with enough time. That's exactly what Patrick Murphy just said in the chat.
Yep.
I don't know. What's your take on that, Sumi? If you don't want to answer it, just leave it alone.
I think Yeri's answer was really great.
Okay. All right. We'll leave it at that. Yeah, because I don't want to, I mean, obviously, you don't want to paint anything in a bad light. I feel like that's kind of like a malicious, thing, more or less. Unless, like, you're trying to recover something you lost personally. That'd be a different story, right? All right. Let's see. What do we have in the Discord questions, Yeti? You want to grab another one from there?
Yeah, 1 second. We got another one. The team mentioned the issues you had with the source code and how it was removed due to a bad actor. Will the source code ever be made open source in the future? I guess that's for the malloc part.
No, he's referring to the miner. And,
okay.
But it has already been published. So it's the GitHub, the repositories are open. Everyone can see how that works. Everyone who's interested to see how, like, OD integration, how the integration steps are being done, can all be found online. But the thing is, obviously, this is a reference miner. So the speed of that reference miner is uncomparable to the commercial miners. I mean, the commercial miners really they optimized it dramatically.
We also had the last question from Serpent actually was, does Dynex believe specialized devices, whether ASICs, FPGAs, or otherwise, will be beneficial or hinder the project, and how? And then the second question to that was, as this can centralize the compute power to a handful of entities like data centers, and is there any concerns with the centralization?
Well, as I said before, right, as we are continuously adding job types, right, and updating the algorithm, I don't see ASICs coming to the game here, to be honest.
Just too much change for them, right? Because they're more or less, for anybody that doesn't know in the chat, they're mining specific machines, so like they can't just do whatever they want. Like FPGAs can be tweaked with a bit stream, right? GPUs can be thrown different algos, whatever, but ASICs are kind of made for one thing and one thing only,
Correct. And I mean, creating an ASIC is quite an effort, financially and from a time perspective.
Right.
So from like the idea to having a full-blown ASIC rolled out, that takes you quite a while. Until that ASIC would be launched, I mean, Dynex would have already 10 different functionalities built in, would be already outdated. So
right.
No, I think the Dynex is going to be a nice and fair place for GPUs for a long time.
That's awesome. I guess follow-up question to that. Somebody said in the chat, UK Miners Club, he said, where do they see themselves in 10 years? Goals, aim for tech. He said, and will they sell if a large company comes in wanting the tech/compute power?
So how should that work? I mean, everything is open source, right? The coins are 100% publicly allocated. I mean, somebody would have to buy all the coins.
Right. You'd have to buy the whole market. Yeah. Good luck, right? Yeah, there's really no way to do that. So, I mean, I get it. But yeah, I guess overall, in 10 years, your goals are to just continue with the biggest supercomputer possible, right? I mean, that would be my guess anyways.
100%. I mean, it's an ambitious goal, but I think it's doable.
Yeah, I don't see why not. I mean, especially with miners. If you get miners on your side, like all of us, it's kind of, I mean, you couldn't ask for more GPUs, right? Like that's It's a honeypot. That's what it is.
It's awesome.
Mr. Yeti, what else you got? You got anything in the?
There's one in the chat actually that I just spotted.
Rip it up.
Would Dynex have access to the customer data set due to machine learning? I mean, federated learning does encrypted training, but basic machine learning doesn't. Asking from a confidentiality perspective.
So, not sure if I understand correctly what he means, but basically, if you look at the PyTorch optimizer, which we are bringing out and publishing, you will see that basically the machine learning task is dramatically encoded, right, before it's being sent to the network.
So regardless of what job, it's all encrypted effectively.
Yeah, of course, right.
Yeah,
and it's important. I mean, the user who was asking that question, right? Sign up for the closed beta. I mean, free computations is what we give them, and we want in return, we want feedback because we need to optimize our systems.
Oh, I'll be signing up probably at the end of this stream, and I can throw some big data sets at you guys to test from my company. So we can definitely help in that regard. I'm more than happy to help.
Great.
So somebody asked a kind of an uncomfortable question, I think it would be for Sumi, but if you don't want to answer it, feel free not to. He just said, will they agree to add a job to the Dynex solver that we provide instead of them showing us results they pre-planned? Will they do it live so we can see the results? It's above my head, so I don't know.
Well, if I'm going to sign up for the beta and I'm going to throw a massive job at them, then we can do that.
Everybody can do it. Every Python capable user can do it. Just sign up for the closed beta, right? And make sure that we receive feedback. Everyone can use it themselves.
I'm more than happy to do that. We can also record it if you don't want to do it live, chum. One way or the other, we can definitely do a video on it, though.
Listen, all that whole sentence is above my head, so if you think it's doable live, we'll do it.
Sure.
That's fine with me. I just wanted to make sure it wasn't like, I don't know, out of line, I guess. I don't know what, like, you know, I just don't want to make you feel uncomfortable. Obviously, I respect you for coming on with us. I think it's awesome that you're here live. It's great. Everybody seems to be getting...
You know, the thing is, it was not even an uncomfortable question, right? Because what we have done is we basically showcase a SAT problem solution solving, right, and compare with other solvers, right? Now that's a constraint satisfaction problem, and very specific one is a so-called 3-SAT problem, and obviously always with new tech there's always question marks. Does it really work? How does it work with other things? You know, how is it really performing better? It's very simple. First of all, there is tons of published research around doing exactly that and confirming what we are doing. It's not that we reinvented the wheel. What we did is we put the pieces together, right, and build it in a decentralized way. And second, the best thing is get more and more customers try it yourself, and that's why we have on all our channels the open invitation, right, for the closed beta of machine learning, for example, right, and that will eventually, the more and more use cases we will see, and the more and more people will have tried it, and the more and more people will see that the effectiveness is actually good for them, the better it is for the Dynex ecosystem. But with always something new, there's always question marks, right?
Of course.
Right. Yeah, it's crazy. I mean, I know you guys have been through, like, you know, a lot of scrutiny in the space, just trying to figure out if this is legit. Obviously, we've dealt with a lot of scammers and all that stuff, so again, that's really the main thing. I really do appreciate you guys coming on and speaking with us. Is there any other questions in the chat, I guess, that I missed, Yeti, if you didn't see?
Just quickly double check.
There was
one from Chadwick Racing.
Okay.
It says, what is the status of the pool reward audit? During AMA number 3, you mentioned this.
No, I'm not sure what he's referring to. Is he referring to an airdrop, or what is he referring to?
Pool rewards audit. I don't know.
That's a very good question.
Oh, yes. I understand what you mean. Pool reward audit. Yes. So basically, when we launched the DynexSolve algorithm in December 1st, right? There was a lot. I mean, there were some hiccups, we must admit, right? I mean, it was not simple. And there was an issue with pool payouts and hash rate and stuff like this. So I announced in the last AMA that we're going to do an airdrop and we can reconcile transactions with the pools. That's ongoing and it's still planned for May.
Okay. Awesome.
Gotcha. I actually just grabbed another one. It says, this is a bit technical. However, how does Dynex directly receive the results of proof of useful work after the miners process the slice of each job?
So we are not constantly sending all voltages and all assignments back to us. That doesn't make any sense, right? We take the key, we take the key information from there, which is like the current energy levels and stuff like this, right? And then from time to time, we basically retrieve the assignments whenever we need them.
That makes total sense, to be honest. All right, let's see. Yeah, I mean, I don't want to take up too much more of your time. I know you're feeling a bit under the weather. Is there any other questions in the chat you guys want to get in before we end up taking off? Red Panda said all in on Dynex with a question mark. So, Panda's going to be all in on Dynex, apparently. Let's see. I'm an ML engineer and Dynex customer, said Samir. Nice. That's awesome. Hell yeah. Good stuff. Man, I mean, personally, I think I'm going to, I have a few rigs that I want to get on to Dynex. And I mean, I love the fact that it has to do with AI for one. I feel like that's the way this country's going at the end of the day. It's going to go towards computational power at some point, right? All over the place. So if we could start with rigs that I already have, it uses way less watts, not killing my electric rate. You know what I mean? It's just, it makes sense for a person like me in my situation to use some of my GPUs to mine, you know, an algorithm like this. But again, with that being said, obviously everybody's got to do everything at their own risk and, you know, to each his own. Some people, this might not be for you. Some people it is for you. It's, you know what I mean? We can't make you guys do it. You got to make your own decisions at the end of the day. I know a lot of people have reservations about a lot of things, but again, the anonymous, right? Anonymity of, you know, Sumi, I get it. I was there when I first started my YouTube channel. I didn't show face. It was more for another business I had on the side. It wasn't for, you know, any specific reason to hide from anybody, right? I mean, I get as like a developer standpoint, it's kind of, or a chief architect, it's kind of one of those things where, you know, he might have other things going on in his life and they're going to come out at their own, you know, pace and all that stuff. So I get that too. Is there anything else you wanted to follow up with, Yeti, before we
there was another question from SockFan that's possibly worth asking, which is, does Dynex plan on showing revenue for the month, a bit like similar to some projects like Flux?
So the marketplace, so currently we show the jobs which are being done, right? And currently as people are just paying solution rewards, we display all those solution rewards. When the marketplace goes live, everything is going to be transparent. How many Dynex have been paid for how many jobs, for what's computation time, etc. Because we believe that showing transparency on the marketplace will increase confidence of potential customers and for the miners.
I totally agree.
I guess there's one thing I missed actually right here. Matt Electron asked, he said, could we get some clarification of the emission schedule? I think that's kind of important, I guess. It's
a classical kryptonite smooth emission curve. So basically, every block, which is 2 minutes, the block reward is being reduced. Takes around 4 to 4.5 years until all blocks are mined, and that's actually also our time frame to ramp up the customer base. So we have enough paying customers that basically the block fees being paid by the customers exceed any potential block reward.
Okay.
But that emission curve itself is in the white paper. It's everywhere. Just following a formula.
Okay. Awesome. Hell yeah. Man, I don't know if there's anything else. I'm trying to see in the chat if there's any other questions. I know Sumi's not feeling too good, so I don't want to keep him too much longer. But anything else you saw, Yeti?
We can do another one when the machine learning is ready. You know, I'm always happy to jump on the channel.
Yeah, that would be amazing, actually. Because I mean, that would give us some time too to get some more questions together and you know, all that stuff. But damn, you're awesome, man. Sumi, thank you so much. I don't even know what else to say besides that. I mean, I know you're not feeling good, but you're great. So yeah, we'll schedule another one, and I appreciate all you guys here hanging out with us and coming to the live stream. And yeah, that's really it. Yeti, you're awesome as always. I appreciate you, man. And we'll do that live stream if you would like with the Dynex
Sure.
solver thing, and we can kind of schedule that with you guys and just go from there.
Super.
All right.
Perfect. Awesome. Thank
All
you so
right,
much.
guys. Have a good day. We'll see you soon. Good luck and peace out.
Thank you.
See ya.
Bye.